Good day, everyone. How are you? I hope you're all doing good right there and fine together with your family. So, our topic for today is synchronous servicing. So, is there anyone have heard about or encountered about this topic? And if you do, you're one step ahead of others. But, however, to those who don't be sad because I'll be discussing to you the simple terms about this synchronous servicing. So, synchronous servicing is more likely a one-way tool in any different company, and because they're assigning more than one machine to an operator is an ideal case where both the worker and the machine are occupied during the whole cycle, which they came up with this formula equation n equals L plus M over L plus W. What is synchronous servicing? So, synchronous servicing is the number of machines that the operator should be assigned under the realistic conditions can be estimated by the lowest whole number from the revised equation. And this is our equation. N sub 1 less than or equal to L plus M over L plus W, where N sub 1 is equal to the lowest whole number and W is the total worker time not directly interacting with the machine, typically walking time to the next machine. So N is the number of machines the operator is assigned. L, the total operator loading and unloading servicing time per machine. M is the total machine running time or automatic power feeding. So, synchronous is the cycle of time with the operator servicing N sub 1. Machines is L plus M. Using N sub 1, we can compute the total expected cost or TEC as follows. So, equation for TEC is TEC N sub 1 equals to quantity L plus M times the quantity of K sub 1 plus N sub 1 times K sub 2 over N sub 1, where TEC is the total expected cost in dollars per unit of production from one machine, while K sub 1 is operator rate in dollars per unit of time, and K sub 2 is cost of machine in dollars per unit of time. So, for example, you're the production manager of the industry or the production industry. So, your boss, the CEO, is ask you to add more machines to an operator. So, as cost should be calculated with N sub 1 plus 1 machine because you're adding one machine assigned to an operator. So, total expected cost with N sub 2 facilities can be solved in this particular equation. So, TEC N sub 2 is equals to quantity L plus W times K sub 1 plus N sub 2 times K sub 2. So, be ready. So, everyone, I hope everyone is listening. So, get your calculator and grab some piece of paper. So, because we're having a sample problem. So, here's it. So, sample problem. The analyst in the Durban company wishes to assign a number of like facilities to an operator based on minimizing the cost per unit of output. A detailed study of the facilities revealed as the following. Loading machine standard time is equals to 0.34 minutes. Unloading machine standard time is equals to 0.26 minutes. Walking time between two machines is equals to 0.6 minutes. Operator rate is $12 per hour. Machine rate, both idle and working, is $18 per hour. And power feed time is 1.48 minutes. The question is, how many of this machine should be assigned to each operator? So, ito na i-solve. So, identifying the given, where L is the loading time, no? loading and loading time. W is the total working time. K sub 1 is operator rate per dollars unit. K2, cost of machine in dollar per unit of time. M is the total machine running of time or power feed. So RL would be 0.34 plus 0.26 as what we what we see in the given. There is a loading and unloading machine standard time in the equation and in the given. So we know that L is the unloading and unloading time, so we add both of that minutes. So we came up with this time 0.6 minutes. And our walking time based on the given is 0.06 minutes. Is it? It's K1, $12 per hour, K2, $18 per hour, and power feed time is 1.48 minutes. Find how many of these machines should be assigned to each operator. Should an operator is assigned 3 or 4 machine? Probably. And also minimizing the cost, which is better. No? Okay. Solution. So we know that N sub 1 is equals to L plus M. So we know that our L is equals to 0.6 and our M is 1.48. Here also 0.6. Our W is 0.06. Am I right? Let me check. Okay, I'm right. So let's solve it. So 0.06 plus 1.48 is equals to 0.8 over 1.48 is 0.6 plus 0.06 is equals to 3.15 units. Oops. But we don't use 0.15 because here in N1 is the lowest whole number, so which is 3. So 3 is the whole number right there. So N1 is equals to 3, right? Let's get that N1 equals 3. So L equals to 0.6, where M is 1.48. Our K sub 1 is 12, am I right? Okay, 12, and sub 1 is 3. Quantity, wait. Our K sub 2 is 18. Okay, now our sub 1 is 3. Let's solve. How much? What is the value? 0.06 is 1.48. 12. Wait, what's happened to this? $18 is equals to 1.37.28. Copy. Okay, I hope sunod mo over 3. So T is C. is equals over 3 equals 45.76. And we know that it is minutes, right? Minutes, right? And we convert it into into R, because R, as we can see here, per hour, our dollar rate is per hour. So let's convert it into divide it into 60. So our TEC would be no. Our TEC in sub 3 is equals to divided by 60 divided by 60. We'll get 0.76 per unit. Dollar per unit. Okay. So next, let's solve for the production rate. So production rate is R. Equation of the production rate is R equals to 60 over L plus M times N sub 1. Okay, we know our N sub 1 is 3, right? So let's solve N sub 1. And it's 3. And our L is 0.6. And our M is 1.48. Let's solve it. 60.6 plus 1.48 times 3. We got rate of production is 86.54%. It's percentage in percentage, because it's the rate of production. It's percentage. So the total expected cost for TEC can be solved in this particular way. No? Here's it. So K sub 1 is 12 plus N sub 1 is 3 times 18. Okay. And our production rate is 86.54. So let's solve it. Let's solve it. Hope all of you sunod dira. So 66 over 86.54. 54. So 0.76, right? No? Similar. Yeah, similar. Dollar, I know, per unit. Wait me, my laptop is running out of power. Just wait me there. Sorry for inconvenience. So our TEC is 0.76 units dollar per unit. So next, our option 2 is if you are asked to add one more assigned machine to an operator. So here's it. Solution is, note that n2 is equals to n plus 1. We know that n1 is equals to 3. So 3 plus 1 equals to 4, right? So our n2 is 4. So L is equals to 0.6. Our W is 0.06. K2, K1 is 12 plus 4. K2 is 18. Alright, K2 is 18. So let's solve. So K is solved. 0.6 plus 0.06 times 12 plus 4, 18 is 18. So AC2 is 55.4 divided by, because it's in minutes, so divided by 60. The EC4, it's 4. I forgot. So is equals to, divided by 60, it's 0.92 per unit. Dollar unit. Let's solve for the production rate. So 0.6, LW is 0.06. So let's solve. So 60 over 0.6 plus 0.06 is equals to 90%, 91%. So our production rate for TEC2 is, now we get higher production rate in this option rather than the first option, which is three machines only. Here in 4 machines we get higher production rate. But let's see the total expected cost, which produce lower cost. Let's solve. So TEC4, K sub 1 is 12, N sub 2 is 4, right? And K sub 2 is 18. And our production rate is 90.91. Solve. Let's solve for this. It's TEC4. No 4. So let's solve. 12 plus 4 times 18 is equals to 84 divided by 90.91%. 0.91% is equals to, by 90.91, 0.92. 0.92 per units. So in conclusion, our TEC N sub 1, which is the first option to have three, no, three machines in one operator. Sorry, 3 machines in one operator is 0.76 units, and the TEC4 in option 2, which we have now 4 machines assigned in one operator, is $0.92 per unit. So since N1 is equals to 3 machine per unit operator produces lower cost per unit rather than in another option, which is 4 machines. Thereby, we conclude that assigning 3 machines per operator is the best option to minimize the cost. So here's our tabular, and here's our tabular for synchronous servicing. So as we can see, here's it. And that's all for today. I hope you understand and get and follow through how to solve for the synchronous servicing. So God bless us all. Thank you and goodbye.